A pleasant day, sir. I am Rachel Manisan, and today we will discuss the biorisk management. And the intended learning outcomes will be explain the biorisk management, discuss the IMP model, and identify risk assessment, mitigation, and performance evaluation procedures. When we're working with infectious agents and toxins in laboratories, we must consider the practices and procedures on biocontainment to ensure biosafety and biosecurity. To carry out total safety of laboratory workers and patients, we need proper management. That is why it is necessary. Biorisk is the risk associated to biological toxins or infectious agents. The source of risk may be unintentional exposure to unauthorized access, accidental release or loss, theft, misuse, diversion, or intentional unauthorized release of biohazards. While biorisk management, it is the integration of biosafety and biosecurity to manage risk when working with biological toxins and infectious agents. And stated by CEN Workshop Agreement or CWA 15793-2011, Biorisk Management or BRM is a system or process to control safety and security risk associated with the handling of storage and disposal of biological agents and toxins in laboratories and facilities.
Hi, my name is J-Rafael. In addition to that, the identification, understanding, and management aspects of a system in interrelated process is encompassed by the BRM or biorisk management. BRM or biorisk management is divided into three primary components, which are assessment, mitigation, and performance. Assessment, mitigation, and performance have been embraced freely by different modern areas for a really long time. Starting around 1989, risk analysis and assessment has extended and has turned into a vital piece of various organizations and ventures. Mitigation control measures offer indispensable tools and practices to reduce risk. Businesses and industries have first identified and saw mitigation measures that will reduce the risk. Next is performance. Performance understands safety record and how to best evaluate the safety performance. Even though many organizations and industries differ on performance metrics. These components called the AMP model or AMP model. AMP model requires that control measure be based on a robust risk assessment in a continuous evaluation of effectiveness and sustainability of the control measure. Identified risk can be mitigated, avoided, limited, transferred to an outside entity or accepted. In addition to that, identified risk is important because it is the first step in the risk management process, which is designed to help companies understand and plan for potential risks or any bad events will happen. We can see the picture that it is a chair, but it shows how the assessment, mitigation, and performance are equal. A biorisk management fails if one of the components or legs is overlooked or is not solved. AMP model focuses on all components with equal attention. We can see the chair that it has three stand or legs symbolize the AMP model. If one of the components or we say the assessment is not equal to the other legs or stand, therefore, the result is the chair will fall down. The same situation will happen if the performance is not equal to other stand or the mitigation is not equal to understand. The result is the biorisk management will fall down or will fails.
Hello everyone, I'm Catherine Mdak and I'm going to talk about the risk management. How many steps have the risk management? Risk management includes identification of hazard and characteristic of risks that are possibly present in the laboratory. Hazard refers to anything in the environment that has potential to cause harm. Risk is generally defined as a possibility that something bad or unpleasant, such as injury or loss, will happen. Following steps of risk management. First, define the situation. Risk assessment team must identify the hazard and risk of laboratory agents to be handled. The first step that the team needed to conduct is a risk assessment. They must identify the situation if there is a hazard and risk on biological agent that needed to be taken care of. Second, define the risk. Risk must include a review of how individuals inside and outside the laboratory may be exposed to the hazards. After identifying the situation, the risk assessment team next step is to define the risk and review on how patient can be affected and exposed to hazard inside and outside the laboratory. Third, characterize the risk. Characterize the risk overall biosafety risk. The risk assessment team need to compare the likelihood and the consequences of infection either qualitatively or quantitatively. The risk assessment team third step is to conduct research for them to be able to compare the likelihood and consequence of the infection. Last step, determine if the risks are acceptable or not. This process of evaluating the biorisk arising from a biohazard takes into account the adequacy of any existing controls and deciding whether or not the biorisk is acceptable. After identifying the characterizing the risk of the assessment team must determine if the risk is acceptable or not. In this process, the team must identify and evaluate the biorisk in order to determine if the biorisk is acceptable or not.
Hi, my name is Jude Elijah P. Flores, and I'm reporting about mitigation procedures. The second key element of biorisk management is mitigation. Biorisk mitigation strategies are actions and controls put in place to lessen or eliminate the risk associated with biological agents and toxins. There are 5 main areas where controls and actions can be taken to reduce the risk. So the first one is elimination, and this is the most difficult and most effective control measures. It also includes the decision to completely refrain from working with a certain biological agent or even from carrying out the intended task. For example, you can eliminate the risk of a fall from height by doing the work at ground level. And without a doubt, the greatest amount of risk reduction comes from elimination. And the second one is substitution control measures, which involves switching out methods or biological agents for equivalent entities in order to lower the risk. For example, using electric motor rather than diesel ones to eliminate diesel exhaust emissions. The third control measure, engineering controls, involves making physical modification to workstations, machinery, manufacturing facilities, or any other pertinent work environment feature that can lessen or eliminate exposure to dangers. Installation of biosafety cabinets, safety gear, facility design that allows proper airflow, ventilation system that assure directed airflow, and air treatment systems to disinfect or eliminate agents from exhaust air are a few examples of engineering controls. The fourth control measure is administrative control. Administrative controls are training, procedure, policy, or shift design that lessen the threat of hazard to an individual. Administrative controls typically change the behavior of people rather than removing the actual hazard or providing personal protective equipment. This may include work process, job rotation, ensuring adequate rest breaks, limiting access to hazardous areas or machinery, and adjusting line speeds. And the last mitigation measure is the use of personal protective equipment or PPE. PPE is a gear used to reduce exposure to risks. Gloves, safety glasses, hard hats, hearing protection, and respirators are a few examples of PPE. PPE is considered as the least effective measure because it only protects the person who is wearing it, and only when it is properly applied.
Good day everyone, my name is Chacha Verdigo, and now let us proceed to the final key component of the biorisk management mode, which is the performance evaluation. The last pillar of the biorisk management model is performance evaluation. That involves a systematic process intended to achieve organizational objectives and goals. This model ensures that the implemented mitigation measures are indeed reducing or eliminating risks. Performance evaluation provides direction for decision makers to be able to come up with reasonable and justifiable biosafety guidelines. The implementation of the entire biorisk management system, including evaluating and ensuring that the system is working the way it was designed. Another aspect of performance is the process of continually improving the system. It also helps to highlight biorisk strategies that are not working effectively and measures that are ineffective or unnecessary. These strategies can be eliminated or can be replaced. Performance management is simply a re-evaluation of the overall mitigation strategy. Here we are re-evaluating the actions and control measures the mitigation strategy have put up. It will show if the 5 major areas of control are being followed. Here we have a diagram that shows the specific procedures in conducting performance evaluation. These procedures are arranged in a chronological order. First, we have to identify the key issues of concern. Next, define the outcome indicators and metrics. Third, define activities indicators and metrics. Fourth, collect data and report indicator results. Fifth, provide findings from performance and indicators. And lastly, we have to evaluate and refine the performance indicators. The idea of robust risk is to assess the worst possible risk when each of the probability measures in the scenario set is possible. The result of a robust risk assessment must be properly recorded, documented, and communicated to all stakeholders of the organization. Only through this final process that findings could be decided upon, given appropriate action to be able to provide and establish clear manifestation of implementing the fundamental concept of biosafety and biosecurity in the laboratory. This concludes our report in Biorisk. Thank you all for watching.